think I heard the gate there again. Alright, we're on the inside. Alright, folks, evening. So we're here again. Day 2 of variance particle questions.
Oh wow, the dessert after that. I have a question for you. Yeah. Do you have question over back here. Yeah. Do you have the shirt? You know anybody that would?
Yeah.
Yes, I do.
So we could start starting.
I don't really know what else to say.
Yes, no.
I wasn't really one in sports.
Alright.
Did she have that?
Hey Noah, evening, how you doing?
Yeah, you think you could like? Oh. You could ask her.
Alright, cool.
You're not blocked. I know I got it. Michigan, I'm so blocked. I know I got it involved. Michigan.
2, 4, 6, 8, 10, 12. I guess, give me 1 sec. One sec, no. 12. Right, there you go.
Yeah, but Rebecca wouldn't have it. I need it for polo, but they never use that for polo before. I'm not sure.
Okay. Alright, folks, so we're starting off with the May 2021 question. Right? Shh. I should be sounding like a spray can in mosquito season, right? Well, I hear and I talking, I should be the only one talking. I should not explain that to form files, but okay, no problem. Right, so we'll take a read the question. I'm going to hand it out here first, sip some tea so I can get a better booming voice to silence the critics. Or anybody did the POA exam today? No? Alright, cool. Oh, that's Christian.
Of course.
Hey Christian, you know how you doing? Yeah, we're not gonna start taking a look at this question, so you didn't miss anything. Right. Should have about 12 copies there. I think there are 2, 4, 6, 8, 10, 12. Yeah, they replaced it for me. I think Kayla printed some stuff, so that might be. Okay. Alright. So when everybody has that copy, we'll take a little read through. Alright, so Christian, Donovan, and Noah. What I'll do, let me actually see if I can send a picture in the chat, right? So that way you all could always pull it up on a different device if necessary. Open a different window. Okay. That's it on?
Yeah,
cool. Alright. Okay, so let's take a read. So this is May 2021. So last week, Wednesday, we did May 2015. And then Jan 2020 and May 2011 were actually very close. They just changed a couple of figures. And we did the Jan 2025 variance question. Alright, so we did the most recent one already. Right, but the other ones are also very much worth doing. So of course, if everybody has one, we'll take a little read and we'll analyze the question, right? So it says that from a harbor H, the bearing of two ships Q and R are 069 and 151 respectively. So from a harbor H, the bearing of Q is 069 degrees and the bearing of R is 151. All right. Q is 175 kilometers from H. So that's this line here. And then R is 242 from H. That's this line. Well, they labeled that one for you already. Right? So the first thing they want you to do is to complete the diagram above to show the information given, right? And then calculate QR, the distance between the two ships to the nearest kilometer. All right? Okay, so I'll give you a minute or so to fill in the rest of the information on the diagram, and then we'll put that in and we'll talk about how to do part 2. All right? And of course, anybody having any issues, let us know. It's not a problem. Mishko or myself could help you out, or you could ask your neighbor for help. Just don't let it into a fish market. Hey, look my wife online. Hello, wife. You had a good time in the pool. Thanks for the pics. All right. Okay, so we could see that the part in yellow, Q, is 175 kilometers from H. That's this piece here. So we label it 175. The 242 is already labeled first, so we don't have to worry about that. The only other thing that's missing is the 151, right? Sorry, hold on. So from the H, the bearing of R, right, is 151. Hold on. 151. All right, cool. 151. Yes, hello, honorable wife. Okay, so check this, right? So what we could do is we could put in the 151 here. Because remember, the bearing of one point from another is the direction of okay, so the bearing of R from Q, of H, sorry, is the direction of R from H given by the clockwise angle. But an angle must be between two lines, right? That meets at the point. And the two lines are the north line at the start point, so the north line at H, and the line connecting the 2 points, in this case, H and R. So the clockwise angle, so it means that the angle going this direction. So that whole angle is 151 degrees, sorry. Right, so they give you 1 mark to do that, so you have that. Right. Now, they want to calculate the distance QR between the two ships. Let me just change that real quick. Give me a second. Right, so this is 175 kilometers. Right, so what we have is we have the length of this line here. I don't know why I got an arrow, but okay. Right, let's do, we have the length of this blue line here. So we have those two lines, and the line we want to find is, let's say this line here, the orange line. All right. Actually, no. You know what? Let's make that green, so it kind of corresponds to the green angle. Actually, no. I'll put it back in orange, right? And I'll tell you why just now. Okay, cool. So we don't know. It doesn't look like a right angle triangle, right? Because there's no marked right angle. So we can use basic sine, cosine, and tangent. But the question is, what can we therefore use? If we can use regular sine, cosine, and tangent, what are we left with? Sine rule and cosine rule, right? So for the cosine rule, we need to have, if we have a triangle, right, and we have two lengths and the angle between those lengths, we can find the length of the unknown side opposite to the angle. So that's what we have. We have two lengths, and we have to find the included angle. We have to find the angle on the inside here. But that's actually pretty easy to do, because if you think about it, all we have to do, anybody have any ideas how to find the orange angle? Correct. All right, so the whole angle from here to here is 151, and this piece is 69. So to find the orange piece on the inside, they will simply find the difference between the two angles, right? So oops. Right, so the value of that angle will be 151 degrees minus 69 degrees. Was that 82? So 82 degrees. All right, cool. So we have our values. Oh, I think I erased something inadvertently there, right? So once, oops, to change the weight back on that pen. 175, right? Okay, cool. So let's give our side some names, right? So this is angle H, and the orange length that we're looking for is opposite. So that's small h. All right. This is R. So that length opposite would be small r. And this is Q. The length opposite would therefore be little q. Right? So we could head up and say, using the cosine rule, any volunteers to call out the formula as it should appear for the working? But we don't have A, B, and C. We have R, Q, and H. Right. So H squared is equal to R squared. Minus. Right. Multiplied by the cosine H. Very good. Okay, guys, so let me give you a little chance to do your substitution, plug in your values there, plug it up in the calculator, and don't forget it's set to the nearest kilometer so you could round off. All right, so I have Christian Donovan and no. Okay, let me actually take my rule. I forgot to take my rule. Oh, and I forgot to send that young lady the link to math class. This whole WhatsApp is down. Let's try that. Gonna have to organize that later. Now, just remember, you're not under exam conditions. If you have any questions you want to ask, please feel free to do so. Eh? Oh, that was Logan. VB's Realty Management Marketing. Evening, how you doing? Interesting. Right, let's start. Sorry, Plaza. Sorry. Evening, Kenny. What vibe? Sorry, yes, question. Right, so the whole angle here was the green 151. That was given to us by the bearing. We said the bearing of R. What am I doing? Okay. Yeah, the bearing of R from H was 151. So that's why the green angle is 151, right? And then the 69 angle was given to us on the diagram. So if 69 goes from here to here and 151 goes from here to here, the angle on the inside would be the difference between the two of them. All right, cool. No problem. That's confident, boy. You don't think you know. All right, there we go. Yeah, sorry guys. TikTok. Trying to pay attention to multiple at the same time. So difficult. All right, cool. Okay, so let's go. So the value of R is 175. So we have 175 squared plus Q squared. Q is the 242. Now minus 175 by 242 by the cosine of 82. So you could plug it, sorry, all that up in your calculator. All right, 2 by 175 by 242 by the cosine of 82. 77,401, anybody? Before the square root? Oh, did it one time? Okay. Right, so to find h, yeah, let's find the square root. All right, cool, thank you. So h would be equal to, now remember they said to round it off to the nearest kilometer. So 278. All right, so 0.2 will round back down to 278. 278 kilometers. All right. So let's zoom out a little bit so we can send that in the chart. May 21. So is this form 5 marks? Yes, it is form 5. Well, form 4, form 5 marks, yes. Definitely. Okay. So Christian, Donovan, and Noah, if you guys are good with that, just kind of give me a G in the chat. If you need me to rework or re-explain, give me an R. If you can be specific about which, I mean, it's only really one or two parts. All right. Well, let me let in Janaya. Oh, and take my rule. I forgot to take my rule. All right. Hey, evening, Janaya. How you doing? All right. Cool. Papa. I heard somebody say something, but I didn't hear what they said. Talk to me. What's up?
How do you could you explain
Oh, my God, what, sorry? Evening, Aisha. How you doing? I'm just trying to hear Christian's question here. Right, that was given to us here. Right, so it says from a harbor H, the bearing of R was 151. All right, so H was here, and R was here, and the bearing of R from H is 151. So the bearing starts from the north line, which is this line here, at the starting point, and you go clockwise until you hit the line joining the 2 points. All right, so that's how you get the 151. Does that help? All right, cool. And you're okay with the cosine rule item on the right-hand side there? Okay, cool. All right, past paper 2025. I did the 2025 last week, Thursday, I believe. Hey, Divya, how you doing? All right, in class, people, anybody have any questions on the solution screen? We good? All right, cool. All right, so let me print out the next one. So 2, 4, 6, 8, 10, 12. Right, cool. And I'll send a picture of this in the chat, right? Yeah, evening, Aisha. I didn't see you in POE, but I'm glad to see you now. We're doing some more bearings past paper questions. We just did one so far. It was a kind of easy warm-up one, so you didn't really miss anything too interesting per se. All right, we're now going to start something a little more interesting here. All right, this is the, like I said, the Jan 2022. So let me send a picture in the chat. What type of question is this under? This is, so James, this is trigonometry, right? Bearings is a part of trigonometry. And on the paper, it would be like question 9, part B.
Oh, Chris,
Yeah.
when you get the chance, press something me, please.
Yeah, for the ad maths class. It keeps, yeah. I have to do that for sure.
If anything, I can just send you a message later tonight.
Yeah, it's there, and I have it marked as unread. So
Okay.
after class, I can try and organize that stuff. Yeah, no problems. Yeah. So yeah, so tomorrow,
Tomorrow I have
Yeah.
4 to 6 and then 6 to 8.
Yeah, yeah. All right, cool.
I'll print out a little calendar and do the phone call.
Yeah. Okay, so, all right. Let's get that given out. I'll give everybody a minute or so to read through. If anybody wants to start on their own, they could go ahead. All right? Because remember, this is not just about watching me work particular stuff. It's about you trying the question and getting it out on your own. And if you encounter any problems, that's okay. That's why you're here, to get the questions to your problems answered.
Everyone got a paper?
Yeah, I printed the extra one for you, in case you wanted to try. So I'll give everyone a couple of minutes to take a read on their own and see what they could pick out, right? Cool. Okay. Right. Lovely. Okay. Yeah, and of course, my online people, so Aisha, Christian, Donovan, Janai, you could always send me pics of your work on WhatsApp directly, yeah, so I can take a look and see what you're doing. Especially if you're having problems, right? Even if you're not having problems, just send me a picture of what you did, so I can take a look.
M26 on printer? M26? Or
426.
yeah, sorry,
Oh.
426.
Yeah. Like, wasn't sure what you was talking about for a second. All right, so let me just take a read through in case anybody was a little stuck. The diagram below shows straight roads connecting the towns L, M, N, and R. Right, so we have L, M, N, and R. Okay, right? LR is 18, which is this distance here. LN is 12, that's that distance there. And MN is 10, that's that distance there. All right? Now, RLN, where's RLN? RLN is 25 degrees. And LMN, so LMN is 88 degrees. Okay, cool. So the diagram shows everything that we have to see, so we'll scroll on so we can see all the requirements. Right? So they want a few things. They want the angle MLN. So MLN is this angle here. 1 second, right? This angle here. All right, so this is item 1. The distance NR. Right? Distance NR is the green line here. So that's item 2. And then the last thing they want us to find is determine the bearing of R from L. Yeah, no problem. The bearing of R from L. So that's this entire angle here. Because remember, the bearing of one point R from a point L is the clockwise angle between the north line at the start point L and the line joining the 2 points. So that whole thing there. Now, given the fact that we have the 50-degree portion and the 25, We really only have to find that piece and just add it together. All right, so yeah, the bulk of the work here is in part one and part two, right? Now in part one, it doesn't look like we have a right angle triangle, so you can't use basic sine, cosine, and tangent. All right, thank you. What about the Monday and Wednesday?
You paid me for that already.
Oh, so this is
So those are the outstanding classes.
this is for last week.
Yes.
All right, yes, good. This is good. Thank you. Right. What was saying? Sorry. Right. Yeah. So because we can't use basic sine, cosine, or tangent, we have to default to what? Either sine rule or cosine rule. Now with this one, we have angles and lengths that are opposite to each other. So the sine rule is probably what you're going to use for that one. And then the distance NR. Right, so look at it. In that triangle, you have two lengths and the angle between them, the included angle. So that one is cosine rule. Straight. Sorry, that weight is too heavy for that particular right triangle. All right.
Remember, we find our building this line here. We have this one and that kind okay. So, okay, right. So, so for the angle, we'll use calculators. So we're gonna put our length on top. So n over sine n equal to x over sine x. And then the next thing, okay, so we're putting money yeah, so you're gonna cross multiply together, you're gonna no, I'll be 12. You, I'll need that instead. Okay. So we're gonna put 12 over sine is equal to 10. I'm gonna cross multiply. Here, so that would be 12 sine. Okay. So that would be we're gonna put 12 is also in sine inverse. Yeah.
That's what you want to call it.
Sine inverse. Whatever. The 12? Oops, I forgot to inverse 12. 12 over there. Yeah, and then when you work that out, so just sine inverse that. Yeah. So I'll leave that there for you. Now you can keep it. I was about to grind your pencil.
So to do that, you want to get rid of the numbers. The operation. By division. Good. So what would happen this time is you multiply by 10. What allows the one side of the equation so when you multiply by 10, you can cancel this and you this sign. Next idea is this the one line. Okay. So that really comes to after the values, you have to do something called sign.
So our formula is going to be m, which is a length, for the angle of sine n, is equal to x, which we're trying to find. Sorry, we have already over the angle of sine. And then we're going to cross multiply and make the angle of x. So that's like I just cross multiplied. So I'll just transfer it. And I'll put it here. Is that okay? Okay. So the next thing I'm gonna do is earlier as well. So I'm gonna divide both sides by 12. How we're doing so far. Um, actually, it's not my favorite. If I put brackets, like putting it in around 10 cents. I think they might have put it as like 80. Yeah. Okay. And then the last thing the last thing you're gonna do is you're gonna sign inverse area.
But a steady degree of accuracy to do.
It's hard. It's I know, so good job. Same answers. Sure. Okay. When you're putting it into your calculator, when you're put the 12 by 70 in brackets, when you're dividing by things, because you might get a different answer because they might think you're doing a fraction. Which you'll get for yeah. Yeah, that's it. Yeah, would you have prepared? Yeah, that's good. Good job.
Something growing on that side.
Yeah, that's good.
All right, folks, I'll reach back on the inside. All right, so how did it go? Right, so to find, oh, I was supposed to draw that in pink. My bad. All right. So that's sign. Huh. Oh, okay. Okay, cool. Hey, I seen the other one. Right, okay. I'll check it just now, right? But it's looking good. To find this answer, again, we're looking for that angle. We have the side opposite, and we have another pair of angle and side, which are mutually opposite. So what that means is that we could use the sine rule. Let me just go down to the slightly thinner point, right? So for part one, the sine rule says that A over sine A, or sine L in this case, right? Let's just put it, yeah, sine L is equal to M over sine M. Now, whenever you're finding angles, what I would suggest is you invert both sides. So you put sine L over 10, and that's equal to sine M over 12. Hey Trish, thanks very much. Hey GG, what's going on? Hey Ace. Right, now we can multiply by 10, right? So you want to find L, right? To do so, you have to remove everything currently attached to it. So we have, right now we're dividing sine L by 10. So let's move the denominator. To do so, we'd multiply by 10 on both sides, right? Doing so will cancel it on this side, And of course, whatever happens to one side of an equation must happen to the next side to maintain the equality, right? So sine m over 12 multiplied by 10. Sorry, that should be 88. My bad. Yeah, m was fine, but we needed the actual value of the angle for it to kind of go anywhere with the working. If we had two unknowns, well, we can't really go much. We can't really go very far with that, right? Okay. So the sine of 88, then divided by 12, then multiplied by 10 was 0.83, blah, blah, blah. So it's approximately equal to 0.83 dot, dot, dot. Therefore, to find L, we have to invert. We have to find the sine inverse of 0.83 dot, dot, dot. So 56.4, let's round it down to the nearest degree. So 56 degrees, right? So 56 degrees to the nearest degree. To the nearest degree. All right, cool. So we have 56. And then to find part 2, so part 2, like we said, was a straight case of cosine rule, right? Because we had the two adjacent sides, adjacent length, and the angle between them, the included angle, right? So for part 2, okay, so maybe I could try and fit it down here, can I? Right, so for part 2, right, it would be that, let's just call it L, right? Because it is technically opposite that vertex, but I mean, so is this. So let's call it NR, right? It's NR. All right, cool. So NR. So NR squared is equal to 12 squared plus 10 squared minus 2 by 12 by 10 by the cosine of 25 degrees, right? That's the angle between them, okay? So again, this is just plug and play. There's no necessity to show every single value there, right? So 12 squared plus 10 squared minus 2 by 10 by 12 by the cosine of 25 degrees. Right, so we get about 26. I didn't see y'all get that, so did I do something wrong? 12 and 18, where I get 10 from, boy? Wow. Okay, so let me go back and fix my stuff. Sorry about that. I do not know where I got. Oh no, I got 10 from here. Oh wow. Right, so let my mistake be your lesson, right? Make sure you're writing the correct figures. Right, so 12 squared plus 18 squared minus brackets 2 by 12 by 18 by 25 cosine, close bracket, equals. So 76. All right, so that's 76 dot dot dot. Therefore, to find the value of NR, it's the square root of said 76 dot dot dot. Square root. So 8.74, right? So approximately 8.7 kilometers. Right? Some of y'all put in 9. Again, if you do that, just state your degree of accuracy, right? Now, we saw on the Jan 2025 paper, right? And I think it started in 2023, that they said your degree of accuracy should be 3 significant figures, and for angles, 1 decimal place, unless the question specifies otherwise. So I do encourage you to follow the instructions on the paper. All right? Okay, all right. And then the last piece was to find the bearing. Right, so again, the bearing of R, sorry, 1 second, my bad. Don't behave yourself. Right, let me get the blue, right. Yeah. The bearing of R from L is given by the clockwise angle, this, which is between the north line at the start point and the line connecting the 2 points, right? So that's the clockwise angle. As we could see, it's simply the sum of all 3 of those angles on the inside. So 50 plus 56 plus 25, let's put that as the value, right? All right, so that's equal to 50 plus 56, which is 106, plus 25, which is 131. Anybody could corroborate 131 degrees? All right, cool. All All right, so let me just zoom out and take a quick pic and send it in the chat, and then I'll take any questions you may have. Right? Don't forget Google Meet. You can send me pics of your work. I have one here to correct, which I will. I will correct. No, we could zoom in there. That's fine. Sorry. Bumped the mic. Right. Number one, let me just crop the edges out of there. Okay, cool. All right, let's zoom back in a little bit more so some of those things are a bit easier. Okay, right. So Google Meet. So Aisha, Christian, Donovan, Janaya, and Noah. If you guys are good with that, give me a Genie chat. If you have any questions, now is a good time to ask. And if you can be specific, right, about what it is you want to rework, that would help. Right? Just like Christian, you could ask a question out loud. It is kind of quiet now, so I should be able to hear a little better. Wait, I didn't take my rule. Right. So Aisha is here, Christian is here, D'Angelo, Donovan is online, right? Juliana and Jaden, Jaira in person, Janaya is online. Xavier is out for now. Jaziri is here, Josiah, I know. Jaquan, not sure, right? Jolie, not here. Cassie is Wednesdays. All right, Khalifa is here, Logan is here, Noah is online with us. Nyla Page, Shamo out, and then Zian. Okay, cool. All right, so that's everybody accounted for. All right. All right, so the next two people who didn't say anything, you have to let me know what's going on, some way, somehow, on WhatsApp. All right, so when you get a chance, you can do so. Thanks very much. All right, so I'm gonna go on to the next question from here. All right. So let me just print this up for everybody in class first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. All right. 13. All right. And while that's printing, let me see if I could. Okay. I'm gonna send this pick in two parts, right? Okay, so I'll send it in the chat. All right. I'll give you all a minute or two to take a little read there. Hopefully it's big enough. All right. So this is the May 2022 question. All right. So it's the question that came after the previous question we just did. All right. So let's take a little read here. So from a port L, so then like this L thing, boy, right? From a port L, our ship R is 250 kilometers, right? That's given to us on a bearing of 65 degrees. So let's put that in a color. Right? Ship T is 180 kilometers from L, right? So ship T is 180 kilometers from L. So that's shown on the diagram. But what's not shown is the next part, which says that it's on a bearing of 148. Now it says the information is illustrated in the diagram below, but as we could see, part of it is not. All right. Okay. So it says copy and complete the diagram above by inserting the value of angle RLT. So RLT is this angle here, right? Now the thing is, how do we find that? What do we know? We know that the bearing of R from L is 65 degrees. So that angle is here. That's 65 there. And we know that the bearing of T from L is 148. So that's this angle here. So to find the angle that they're asking us for, which is RLT, we would have to subtract, right? Green minus pink. All right, cool. So the pink angle corresponds to the yellow, and that is 65 degrees. The green corresponds to the green, and that's 148, right? So when you find the difference, what do we get? 83. All right, so that's 83 degrees. So that's the value of angle RLT. Now they then want RT, the distance between the two ships. All right, RT, the distance, sorry, one sec. Right, which of course is this distance here, RT, the orange line. Right, and then they wanted the bearing of T from R. That one is a little interesting. Right, so start off with finding the orange one. The orange length, sorry. Right, by now I think we know that we're using cosine rule because we have two adjacent sides and the included angle. All right, so you could use your cosine rule for that one. And if anybody is trying to find the bearing of T from R, right, I'll give you a little hint here, right? What you should do is draw a north line at R and then draw in where the bearing would be. GL Customs, even in GL Customs, how you doing? Doing some bearings past paper questions tonight. Right, and Google Meet, if you all have any questions, please feel free to let me know. It's not a problem. That's what we're here. All right, so I'll give you all a little time. We will then walk around and take a look and see what's going on. And those online, of course, could send pics. Speaking of which, I had checked on don't know one stuff yet. Okay, cool. Oh, Ethan, how you doing, man? How you going? Sorry. Didn't recognize you. Please put the name now. Yeah.
I'm looking at the currents right now, so we can start going out. But how did this 115 come around?
Right. If you extend this straight line, you have parallel lines.
Yeah.
Doesn't-
Oh, and subtract from 180.
Correct.
Okay, cool. Thank you.
Yeah.
Then from 360.
Okay.
You heard the explanation, you want me to go through them? So you find these two angles first. This one can be found on the side. Yeah. Oh, no, this one is 65. On this side will be 65 because of the F angles. Just to this side. So we could subtract the right from 180 because we have also like the angle on a straight line to minus 1. Subtract everything from 360. Hey, you Sure. Okay, so this angle will be 65, on this side will be 65, because you see like you kind of have points on. So this side is 65. So you find this angle right here by subtracting 65 from the new, because the angle on a straight line is 180. Didn't cancel the division to part. Okay. So find this angle inside here by using sine theta. Then what also we'll do is you want to find kind of the opposite of what you have. You'll subtract both of these angles from 360 to find the bearing. Okay, hold on. Alright, that's a bearing. You found the first support. That's a bearing. Okay, so I'll first got this angle right here is we took away this angle and we put it in.
Okay.
Right, so
Oh, all right. Later. So tomorrow then, Matt, right?
yeah.
You're gonna list of topics, yeah? I like differentiation. This angle and this angle are not because you don't have north lines and then you get so that's 65. So you can find the rest of this angle because it's a straight line. It's 180. So you also subtract 65 from 180 to find this. To find this angle, you want to use sine theta, which is the line over the angle of the angle. Okay, so once you find this and this, your bearing is gonna be all that. So you can, which will do it, you're gonna subtract this angle and this angle from 360, because you want your rest to go. So that's basically what you kind of have a lot. Is that like that? But like, you kind of see the general what's going on. Yeah, you're smart, you'll understand. So, good luck. Yeah. Okay, so first thing we're gonna do is a little more line, and then I'm gonna extend this angle out. So that creates the F angle for this angle right here. So this is gonna correspond to this. That's like, Yeah, so
you know that's. Okay, so you'll find this angle by subtracting 65 from 180. Yeah. So that'll be that. You can use sine rule to find this. Because two angles, two sides of an angle.
Yeah.
And then, okay, so once you find this and this, you kind of make the opposite of what you have. So you kind of take two angles, from 360. So yeah, okay. So, I know that was a lot. If you want, I can go do that again. Okay, so you already have all the 65. Yeah. So then we're gonna sine rule for this. So if you have these two angles, or you know how you're finding on there is you start from wherever the answer that comes after from. So is that from R? So we'll start with the lower line and we'll go clockwise until we hit the line of the existing word, which is T right here. So you kind of see how, okay, so we have the shaded parts, but we don't have the unshaded parts. This whole thing makes a circle. So we can find what we don't have, like what we don't have, by subtracting what we have from the total, which is the 360. So once you find these two angles, you subtract that from 360, and that will consist of the rest of it.
So you have your voice. Oh, stick around. See that?
I use cosine. Yeah, you can use cosine for that because you have your angle on your sides of like on each side of it. But this one sine rule because you just have two random like lengths and an angle.
But this is the angle.
This angle right here that you're trying to find. So sine rule is the length of the lines over its corresponding angle is equal to the next line over the corresponding angle. So you have this length, which you just found, these two. You don't know what this angle is, but you have it for. So you'll substitute the 3 what you have to substitute that with the 3 one angle to lights. When you put it in, you'll have like x defined. And then you just transfer those around. Kind of see the vision? Yeah. Okay.
Because this piece is
You said to subtract the 260.
Okay, so when you're finding okay, so say we're finding this code and so how we find actually is we're gonna start the point from so we'll look into that so we're gonna start this is our T-line. So we started in one line and
alright, so let's starting there with the
yeah. So
orange RT. So that's cosine, a straight cosine rule shot, right?
But what you don't have is this.
So RT squared is equal to 250 squared plus 180 squared minus 2 by 250 by 180 by the cosine of the 83-degree angle we found on the inside. Right, so let's plug that up in our calculator and see what we get. 250 squared plus 180 squared minus 2 by 250 by 180 by the cosine of 83 degrees, close brackets, equals. Right, so I got this value. So I think I was working with somebody, I don't remember seeing this, but did I do something wrong? 250 and 180.
No, that was good.
Okay, 83, 931. Okay, cool. Thank you. So that's 83, 931. Therefore, to find the value of RT, we have to undo the square. To undo the square, you have to find the square root. What? Hold on. Okay. Right, so square root that. So 289.7, so approximately 290. All right. All right, so that one is about 290 kilometers. All right, so we'll just shift that down a little bit because I want to shift this down too. Okay. So that first piece there was the part 2, right? Now, we want the bearing of T from R. So this is where it gets a little involved, right? This is kind of more along the lines of some of the older bearings questions. Right? Some of the older bearings questions, right? Which to me, right, it's supposed to be challenging, right? It's supposed to be prepped a particular way for the exam. Anyhow, so the bearing of T from R, again, is the clockwise angle from the north line at the start point to the line connecting the 2 points, right? Now, how do we find this, right? Now, we have a couple of different ways to find it, so this is what I'm going to show you, right? So, remember last week, Monday, if you can, when we did like the original version of bearings, right? What we did sometimes is we extended the line joining 2 points, but we're not going to extend the orange line. Let's extend this line here. If you extend that line, what you're going to see is that you have a north line here and a north line here, right? That means, sorry, don't forget, and all north lines are parallel. So if you have parallel lines, that gives you scope for F and Z angles, all right? So what do we know about F angles? So in this case, it's F angles, they're corresponding angles. So this angle here would be equal to this angle here. So that's 65 degrees. But then you might ask, well, how do I find this angle here? Because what I would need to find the full bearing is to find this angle here and add it to 65, right? Now, we have a couple different ways we could finish the question. One way, right, is to find this angle here. Now, what do you notice about this line here? It is a straight line, and the angle on a straight line is equal to 180 degrees. So if I were to find this angle on the inside here, I could then subtract it from 180, and then that would give me this angle on the outside here, not so? And then I could do what? Add that to the 65. So that's one way you could work it. The other way you could work it is you could say, hey, I actually could find this angle on the outside here very easily because, again, this is a straight line, and the angle on a straight line is equal to 180 degrees. And if I know this piece is 65, I could very easily find this piece. That's 150. That was 180 minus the 65, right? And then what I could then do is find this angle on the inside here. What that would do is it would give me like the remainder of the circle here. And what is the total number of degrees in a circle? 360. So if I find this portion of it, I could simply subtract that from 360 and find the purple angle, which is the bearing I'm looking for. But either way you take it, you had to find this angle on the inside here, right? Now, to find that angle on the inside there, we know the length to which it is opposite, or the length which is opposite to it, right? We know this length here, right? And we also have one other pair of angle and side, which is mutually parallel. So which rule do we know that uses opposite angles and sides? The sine rule. So we could use the sine rule to find the unknown angle here up in the corner, and then from there you could decide whether to subtract that from 180 to find this piece and then add it to 65, or you could add it. You could add that piece to the 115, and then subtract that total from 360 to find the purple angle on the right-hand side. So what we're going to do is we're going to do, well, we had to find that angle. So let's find that angle, right? Right, so to find that angle, that's angle R, right? Okay, cool. So we'll do 180. Sorry, that's not degrees. 180 is the length, right? 180 over sine R is equal to 290 over sine 83. And like I said, when you're finding angles, what I suggest strongly is you invert both sides to put the angle as the numerator. Well, the sine of the angle, that is. We could then multiply by the denominator on both sides of the equation. All right, so now we have to plug that up in the calculator. So 83 sine divided by 290, then by 180. So 0.616, okay, cool. So, sorry, so that is equal to 0.616 dot, dot, dot. So to find R, you have to undo the sign. To undo the sign, you have to find the sign inverse of 0.61. Sorry, one sec. So let's just find the sign inverse of that. So about 38 degrees. Oh, look at that, not bad. 38 degrees to the nearest. Well, even to one decimal, it's 38.0, right? Because it was 0.02. All right. Okay, so we found the value of this angle on top of here, which is 38 degrees. Let's put that in a kind of pink to make it start. So 38 degrees. Right, so check it. So again, right, so we could find the purple angle, the purple piece on the outside here. So 38 from 180 will give us 142. So that's 180 minus the 38 degrees. And then you could add 65 and 142 and get 207. And that would be the bearing of T from R. Right? If you took the 38 and added it to 115, you would get, well, yeah, you get 153, I think. And if you take 360 and minus 153, you again get 207. So whichever way you choose to find it, you should get 207 degrees. All right? So the bearing of T from R is equal to, so 65 plus the, how much? 142, sorry. 207 degrees. Right, so I know it's kind of looking small, but let me just send a picture in the chat. And I will send a PDF with everything we did today, so you don't have to worry if things too small, right? I mean, they send about the same size. We'll see how it goes. All right, so let's see. Crop that so, crop that so. Let's see, does that help? Yeah, it's how to zoom in here anyway, you take it, but anyway. Right, so I'm gonna zoom back in on top of here so we can see the pieces that are working, right? So right, so some of these questions, so this was actually not that long ago. This was 3 years ago, 2.5 technically, right? And again, you had to think through the question, right? Now, I didn't put in number of marks for the question, but again, when you see your paper, you will know how many marks there, right? So let's say worst case scenario, you really couldn't figure it out, but you're able to get little bits and pieces. Do what you could do, all right? I gotta be careful how I say this next part. You don't have to get everything right to get a 1 or to pass, right? But I don't want you to use that as an excuse to leave out entire topics in your revision and say, I could still pass because Chris said I'd answer everything. I'm not saying that, right? I'm just saying, even if you have to try your hardest to get as many marks as possible. You probably will not get 100%. I don't know that anybody actually does, right? But given the fact that almost no one gets 100%, but people still get 1s, 2s, and pass with a 3, you could more than do that as well. But you have to do as much work as possible. Sometimes there'll be things that let's say you weren't properly prepared for. Like last year in the May 2024 paper, the question 2, the algebra. that everybody say will throw them off, right? If you're in an exam and a question start to make your brain hurt early on, turn the page, close your eyes, do a minute or two of deep breathing, forget the question, and move on. I'm serious, right? Come back to it. It makes no sense trying to fresh, especially if it's a question two or question one. Question one in the exam last week had an error. One part B. And if question one part B have an error, and you're like, but this question's supposed to be easy. I must be missing something. And you start to doubt yourself when it's their fault. Who gonna suffer? You. Don't suffer unnecessarily because of CXC stupidness, right? CXC stands for can't examine correctly, right? Or can't exactly communicate. So you had to manage yourself in the exam. They're not going to do it for you, right? Don't get gray hair like me. That's not because of the exam, it's because I will, right? So in the exam, please walk with a watch, right? And manage your time. You have 10 questions. How long is the exam? 2 hours and 40 minutes. How many minutes in an hour? 60. What's 2 by 60? 120. 120 plus 40 is 160. So 160 divided by 10 is 60 minutes. So you have 16 minutes a question. Some of the questions will take you 5-7 minutes. Some might take you 20. That's okay. It'll average out, but you have to watch your time, right? I used to take off my watch, put it in front of me, and every time I start a question, I watch. So I have 20 minutes. Cool. All right. You had to watch your time in the exam. Nobody else gonna watch it for you. All you'll hear is 5 minutes left. I'll be like, oh, I am question 3. Oh shit, right? So yeah, don't find yourself in that particular situation, right? And we have time before the exam, so we have time to prep for it, right? And and like I was saying, after today, we spend in one more day on bearings, passive question. Next week, we're going to linear programming. That should take us the rest of January, and from the start of February, we get in past papers whole, right? It takes about 3 sessions to go through a whole paper because I don't rush things, right? But all this stuff is available ahead of time if you need it, right? We'll probably be able to finish, let me tell you, assuming mock is just after Carnival. I like May. Mock starts during CSEC. March 9th, okay. So they give you, it can't be the 9th because the 9th is a Sunday. The 10th, okay. So we might be able to get through about 5 papers before mock exams start. During mock, we'll still keep doing papers. We won't do anything new. I don't think we have anything new to do. And then after mock in the Easter break, we will be continuing past papers right up until the exam. We actually have a nice space between PUA and maths that week. PUA, I think, is in Monday to Tuesday. We have a couple other stuff that people doing, but the majority of people could come and just beat maths to death. Anyhow, folks, we have half an hour again. I have at least one more question for all, yeah? All right, so let me just print it out. All right, the copy I got of this paper wasn't that great. As you can see, we have a little curvature of the words in these things, right? Print. All right, cool. So I'll send it to print. For my online people, of course, it's going to be visible all the time, but I'll send it here as well in the chart. Cool. Oh no, it's on the paper.
Oh!
All right, so you can just print in. Those online could go ahead if you want. Take a read.
Imagine.
short.
Oh, that's from the last one.
Yeah. Did anybody not get a printout to the last question?
Oh.
Well, I guess I'll send it again. I think everything is visible there. Yeah, so Google Meet, you can go ahead and try if you all want. Hey, Sadhana, how you doing? Oh, Sadhana gone. Cool. Hema. Nicholas 25. What vibes? Everybody good? Oh no. Wow, that's pretty cool. All right. So this is the May 2023 question. So it says the diagram shows a triangular field LMP on horizontal ground. Okay. So we have LMP of a north line at L. So they want the value of angle MLP. MLP as that angle there. Oh, let me get a slightly heavier weight on that point. Okay, well, look, that's the angle there, right? MLP. Now, we have a triangle, right? We have any angles? No. We have any lengths? We have all three lengths. So what do we do when we have all three lengths and they want to find an angle? Which rule do we use? Cosine rule. Pythagoras applies to right angle triangles, right? The cosine rule is actually Pythagoras with a modifier, right? So you're not fully wrong. You just didn't fully give the answer. Anyhow, so what you could do here is, all right, this is the length opposite the angle, right? So that's small l, sorry. That's small l. That is small p, and that is small m. All right. So if you were doing the cosine rule here to find that thing there, it would have been that L squared is equal to m squared plus p squared minus 2 by m by p cosine L. And if we're looking for the angle L, you're going to have to make this piece here the subject to the formula. So if you want, you could transpose it using just the letters, the algebra. If you want to put in the figures and transpose, you could do that too. That would be a little more cumbersome and take a little more time, but nothing is wrong with that. You could do it that way too. All right. So let's start there. So I want y'all to make cosine L the subject of the formula. And remember, this whole thing here is like a single term, right? Okay. Well, it's all connected by multiplication. So it's a single product. Okay. As well. Finally catch up with she had. Right, sorry, give me 1 sec. I have a lot of water bottles here to throw out. Oops. Oh, there's a squashed one there too. Bag is full.
That's no water almost. Chris, what's your birthday?
When is my birthday? 30th of August. 7 months up.
Okay, so we
That's
we
one
hit
we
February.
post CXC, post IC, post readiness. So
Yeah, Chris, we're gonna give you a housing,
alright.
which is gonna be our last one. Because we go to school.
Oh, I keep forgetting this is my wife's
Yeah.
As I say this time, I Good enough? They get you anything? Look at that. Something going wrong. I think we have it. Both my sons have music congestion.
Yeah, I don't know what's going on.
So I don't know if they get smart tools sorted.
Um,
I always had a coffee later. 1 o'clock in the morning. This
no, like, okay, so you subtract the finance, right? That's
as we start to
subtract the two to get on this side.
Last week I was still stumped.
Oh, you can divide this by 20. Wait, this would still be 90 on the side. Yeah, so the graph is divided by 90.
You know even the way in through?
Yeah. And then you have the ideas, but if you simplify that out to
Start off very
side
simple.
person.
This side here is L.
No, okay.
This side here is small.
You want to start the job? Okay. So yeah, subtract the C divide by
Usually
minus
percent.
2 and then constant percent.
Usually if we have the answer, we try and find out. Yeah, you just put
You'll cross reverse. Which will
find
cancel.
out. Yes, the one at a time.
Let me do that again. Want me to do that again?
You don't have to find out.
Yeah.
You can find this one. Ready? Ready? But M from yeah. No, M from L. M from L.
Yeah, and then onto
So
the
if you
outside.
have the whole angle,
Everything will move in.
I have
But see your transpose are around. So yeah.
that's
So yeah. I didn't say anything.
L from
Yeah. How do I not do it? We can see it. Huh? How are you seeing it? Well, see, not you're not seeing it, but like, yeah. But like, how do you see it for C-sec? For C-sec? No, but they have to not, we can. That's the way from as far back as you can. It's like less, like, probably, yeah. And we each, yeah, just put that as with all the answers. Yeah. I did that for science.
Okay, let me see if I can help you all out here.
Because
Just in the interest of making sure we don't go too much overtime. Yeah. All right, so ladies and gents, let me help you with the transposition, right? So check this, right? We're trying to find for cosine L, right? So some of you all, I saw a couple interesting things. Somebody carried across the m and the p. So what that person did was they subtracted the m squared and the p squared from both sides, and they were left with minus 2mp cosine L. And then to find the cosine L, you have to move this piece, which means you have to divide by it because you're multiplying the minus 2mp by cosine L. So you could do L squared minus m squared minus p squared all over minus 2mp. So you could do that, all right? So therefore, cosine L is equal to, right, what's the values now? That's m, and so L squared, L is 180 squared minus 150 squared minus 120 squared all over 2 by 150 by 120. All right, so you could just plug that into your calculator. 180 squared minus 150 squared minus 120 squared equals, right? And we're going to divide that by negative 2 by 150 by 120. Oh no, I didn't press, I pressed minus, oh crap. Okay, so it was minus 4,500 divided by 2 by, okay, 2 by 150 by 120. Right, so 0.125. Anybody got 0.1? Oh, sorry, someone only got it. Right, so cosine, sorry, let's put it here. So 1.125 is exactly 1/8. Right, so to find L, what we need to do is find the cos inverse of 1/8. So 82.8, let's round it off to 83 degrees. So approximately 83 degrees. Right, so again, let's just recap that, right? So in trying to make cos L the subject, right, we could take across the m squared and p squared, right, by subtracting both of them and then dividing by minus 2mp, right? Now don't forget, don't disappear the minus sign. Sorry, one sec. All right, cool, yeah. So when you do that now, you make your substitution. So the 180 is the L, then we have 150, 120, boom, boom, boom. Right, okay. Let me just cross-check it with last year, May 2023, right? May 2023. Yeah, 83 degrees approximately. Okay, not bad. Okay, let me zoom out of that a little bit. So I'll send that in the chart first. Okay. Right, the next thing they asked for, they said the bearing of P from L is 210 degrees. The bearing of P from L, right? P from L, that bearing is again the clockwise angle starting from the north line at L and going until it hits the line joining L and P. So it's the clockwise angle. So this whole angle here, right? So that whole angle is 210. Right, so the whole thing is 210 degrees. We just found that the pink piece on the inside was 83, which would correspond to this piece as well. Now the first thing they want is what is the bearing of M from L, right? the bearing of M from L would be this blue angle here, which would correspond to the external piece of the green angle. So all we'd have to do is take 83 and subtract it from 210. (210 minus 80 is 130. 130 minus 3 is 127 degrees. Yeah, sorry, I kind of took that away from you all and did it myself. Sorry about that. Okay, well, that's all right. Now the final thing is to calculate the value of angle NLP. NLP, which is, hold on, let me show you. Right, so NLP is this angle here. And hence find the bearing of L from P. So the bearing of L from P means you have to put a north line at P and do the clockwise angle between P and the line connecting P and L. So you're going to have to use the orange angle to find the purple angle. But you have to find both. They want the value of angle NLP and hence the bearing of L from P. So I'll give you a couple minutes to look at it. It's actually kind of staring you in the face there. I'll give you a hint. What is the value of the sum of the angles at the point? 360. Right. I'll say no more. So I'll give you a few minutes. If anybody has any ideas you want to toss out, you could. Yeah, go ahead.
Extend this line, make the F angle, subtract 180 from 210, and I'll be equal to this.
Let's see if we do that. Well, 210 is that. If we do that, yes. That probably would be the easiest thing to do, to be honest. Yeah. Explain which one? The bearing of M from L. Okay, cool, right. So the angle we want, so sorry, they gave us the green one, right? They told us that the bearing of P from L is 210. Yeah? Right? So that is the green angle. Right? P from L means that you have to have the north line at L is the starting point. So you have to start the clockwise angle there and travel until you hit the line connecting P and L. Are you okay with that? Yeah. Right. So that's 210. And in the previous part of the question, we found that the angle on the inside here was 83 degrees. What they want is the bearing of M from L. Right? That bearing, again, starts from here and goes here. Right? Yeah, Julie. So if we have the green, right, which is 210, and we have the internal portion, which is the 83, to find the external, we simply find the difference. You've seen that the green angle goes from this line to this line, right? Yeah. And you've seen that we could actually break that angle up into two pieces, this piece here and that piece there, right? So if the whole green is 210 and the internal piece here is 83. So that was yeah. give you a little time again. Emphasis on a little.
You're not supposed to say that.
You want Vicky first? Me and Vicky? Oh. Yeah. I don't know, she was messaging me. I'll see if my friend is she's on message my picture, it's such a fool. I just told her to message me.
Wait, what is she not doing?
Yeah, okay, that's a super question.
Oh, no, I don't see you online. That's what I mean. I can't understand.
Okay, okay, I you heard it.
I might have to go wrong too.
You heard it.
You know what? I always and
Everyone knows who you always.
and one. Always and always downstairs. She's always upstairs.
And you all know.
Huh?
You all know. You sure if you want?
And you
Easy.
have you ever not seen me anymore?
Right. Let's go. Okay, so like we said, the sum of the angles at a point, which is again this if you complete this circle on the outside here, right? The whole circle is how many degrees? 360. Now the green and the orange make up the whole 360. So if we have the green to find the orange, what will we do? Subtract 210 from 360, right? So 360 minus 210 is equal to how much? 150, right? So this angle here is 150 degrees. And then they asked for the bearing of L from P. The bearing of L from P is this purple angle down here. Now, what we could do, right, is you could acknowledge that those two angles, the purple and orange, and the purple one down here and the orange one are what we call co-interior angles, which are supplementary, and they add up to 180. Or you can do that trick that we learned last week Monday and extend the line joining the 2 points, which would make the F angles apparent. So this angle here and this piece here would be equal. And since this is a straight line, the angle is 180. And the 150 portion would make this side here 30 degrees. So this angle is 30 degrees. Right? The other way to find that is the same. If you extend that same line, right? The whole green angle was 210. This piece here was 180. If you take 180 from 210, you get the same 30 degrees. So you had different ways to find the angle. Right. Okay. So NLP was equal to 150 degrees, and that was 30 degrees. All right, so that was the 360 minus 210, and then 180 minus 150. All right, so let me take a picture and send that for you guys in the chat. But yeah, we will stop there for today. Before we run off, right? Before we run off, right. So folks, as we see, the questions do get a little challenging from time to time, right? So those are some recent questions. You will notice a bit of an absence of 2024, which probably means there were no variance questions in 2024. But we had in 2025, 2023, 2022, 2021, 2020. All right. Shh. We're not done. We're not done. right? So as you can see, it does come relatively often, right? Just that in 2024 it was not present, right? So again, we are practically in the middle of January, all right? So we're going to spend one more day on Behrens participle questions, and then we're going to see if we can knock off linear programming in 4 sessions, right? The first 2 sessions are pretty easy. The first session, you're literally just drawing lines, and I'll teach you how to draw. It sounds stupid, but I'll show you how to do it. The next session, we'll be dealing with inequality statements, turning English into mathematical statements, and then starting to show them on diagrams, combining session 1 and session 2, which will lead into the participle sessions of session 3 and 4, and it may extend into February, right? So therefore, it means in February, if we finish linear programming in January, we could do 1, 2, 3. Well, actually, there's no class here because that's kind of one day. We could probably get 3 whole papers done before mock. If we're lucky, maybe 4, right? And let's keep continuing from there. Right, now, if anybody has any topics still outstanding that they don't understand, that they need replays for, you have to let me know. Because my plan is not to go over any topic from scratch per se, but to revise it on the go while doing participle questions, right? I think I was discussing with Julia at the start of class, stuff like statistics, measurement, which is area, volume, surface area, the sequences question, the patterns question. We'll do those things on the go, right? In the years where where COVID was still kind of a thing in 2020, 2021, maybe 2022, where we had extra time before the exam, which we no longer have, I used to do 3 sessions just on the sequences. We don't have that time again, but I have those recordings, right? So if you want those, you could let me know. We could organize, right? But I would encourage you to go through your syllabus or your list of topics that you have somewhere, see what you need to know, see what you don't know, and if I have replays, I could send them to you, all right? Anyhow, so folks, that's about it for today. If anybody has any questions you didn't get to ask during class, especially with this topic, because I know it's a bit of a problem, send me a WhatsApp, all right? Once I have a little time, I'll get back to you. Other than that, have a good evening. See you on Wednesday. Bye. All right, Google Meet, I'll go on there. I'll see you guys Wednesday. Bye.